So, good morning to one and all. Today we have discussed the analysis of truss. In the previous lecture, we have discussed how to analyze the beam that is related with the slope and deflection. Okay. Here also we have discussed the um, deflection, or we can say that the analysis of truss is related with the either we can find out the uh, forces in the members, or we can find out the external reactions and the deflection. Okay, so let us start. As we know that in truss, all the joints are hinge or pin connected. And second thing, whatever the load acting on the truss, always acting only at the joint, not on the member. Third is the we have neglect the cell plate of the truss. These are the few assumptions. Otherwise, if the load is acting in between or on the member, then we have not considered as a truss, it is considered as a frame. Okay. So, first of all, we have discussed about the degree of static redundancy and kinematic redundancy. So, we know that DSI, degree of static redundancy for the truss, is equal to, again, external is related with the number of reaction components minus number of equations, and internal. Now this internal is related with, for simple truss, we have considered m minus 2j minus 3. So this is related with the simple truss, and for the we can say that the cantilever truss we have considered m minus 2j. Okay, so here this is the truss. When we consider the number of unknown supports or unknown reactions, one is vertical reaction at support D, and at support D again there is a horizontal reaction. So H is there and here V is there, vertical and the horizontal. Similarly at F there is only roller support, that's why only one. Therefore the value of R is equal to, we can say that 3, and the value of E, that is the number of equation available, is always 3. That is the equilibrium equation. So 3 minus 3, it is 0. Externally the given truss is determinate. But what about the internal? Internal number of members available are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 members, and the number of joints 1, 2, 3, 4, 5, and 6. So 6 multiplied by 2, it is 12, minus 3. So it is 9. So 11 plus 11 and minus 9. The degree of static redundancy is 2. That is the internal. Okay. Similarly, we can find out the degree of kinematic redundancy, dki, as we have discussed in the previous lecture. Dki here in truss, all the joints are pin connected, and that's why there are only two translation. One is vertical and one is horizontal at every joint. That's why at joint A 2, B 2, and C 2, that is total is 6. At E 2 again 8, but at F there is a roller support. That's why only one possibility, that is the translation about the x-axis, and for D joint there is restriction because of the reaction. It cannot move in x direction or y direction, that's why 0. So 2 plus 2 plus 2 plus 2, that is 8, plus 1 9. So dki is equal to 9. This is the degree of redundancy or indeterminacy. Similarly for this truss, second truss, here it is observed that at support, at one support we have considered say two reactions, vertical and the horizontal. Okay. Similarly, at support, another support, there is a roller support. That's why 1. Therefore, R is equal to 3 and equation available are 3. That's why R minus R, it is 0. But what about the internal? For internal, there are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 joints are there. 5 multiplied by 2, it is 10. 10 minus 3, it is 9. Right? So 2j minus 3, it is 9. But the members are 1, 2, 3, 4, 5, 6. There are 6 members and 2j minus 3, 1, 2, 3, 4, 5 multiplied by 2, that is 10 minus 3, 10, sorry, it is 7. 10 minus 3, it is 7, not 9. So 6 minus 7, the answer is minus 1. And that's why we can say that this truss is deficient or unstable because we need this member, otherwise it can move in this direction. That's why this is the degree of static redundancy, minus 1. What about the kinematic? Here two translation, here two translation, here two translation, and here one, because the roller is there and at this support hinge is there. That's why 0. 2 plus 2 plus 2, that is 6 plus 1, 7. So dki is equal to 7. So this is related with the, we can say that, degree of static redundancy and kinematic redundancy for the, we can say that, the truss. So let us start the analysis of the truss. For the analysis of truss, we have used the strain energy method, or we can say that the unit load method. So for the unit load method, we can analyze the truss. That means first of all we can find out the support reaction. Then we can find out the forces in the truss, that is called as the P force analysis. Then if I want the deflection at say point E, in that case we can apply the unit load and it is called as the K force analysis. Then again repeat the same procedure, find out the forces in all the member, and then we can take Pk into L, that is the length of each member, divided by A multiplied by E, that gives the deflection at point E. That means we can apply the, if I want the deflection at E, we can apply the point load, unit load at point E. If I want the deflection at B, we can apply the point load or unit load at B, like that. Okay, so let us start. First, we have taken one problem. Okay. Uh, yes. Yes. Determine forces in the member. Just a minute. Hmm. Yes. So analyze the truss. The problem is analyze the truss loaded and supported as shown in figure. Calculate the vertical deflection. If the area of all members are same, 1200 mm square, and the modulus of velocity is equal to 2 into 10 raised to the power 5, and what are the expectation? Support reaction, sketch the P force analysis, sketch the K force analysis, and the vertical deflection at C. So first we will see the diagram. Now this is the truss. Of course, we can say that this is the cantilever truss. It is free at the end D, and then here roller is there and hinge is there. That's why the degree of redundancy is 0. R minus E, 3 unknowns and 3 equation. That's why it is 0. Similarly, M minus 2J minus M minus 2J or M minus 2J minus 3, we get the 0. So it is externally as well as internally determinate. Okay. So here there are two forces acting. One is horizontal 15 kilonewton and one is vertical 35 kilonewton. First of all, we can find out the support reaction. This is the step number 1. And we know that in engineering mechanics, we have studied the application of equilibrium. Summation Fx is equal to 0, summation Fy is equal to 0, and moment about particular point is equal to 0. And we get the HA, VA, and SC. So this is the calculation. Summation Fx is equal to 0, HA horizontal reaction at A, SC horizontal reaction at C, minus this is 15 is equal to 0. The value of direction of HA is taken in this direction. That's why this is minus, this is plus, and this is plus is equal to 0. So HA minus SC is equal to 15. This is the equation number 1. Similarly, we have applied the summation Fy is equal to 0. Vertical reaction, say VA or RA at support A. Upward direction minus 35 in downward direction is equal to 0. That's why we get the vertical reaction at A is 35 kilonewton. Then we can apply the moment at point A and we get HC is equal to 22.025 kilonewton and HA is equal to 37.025 kilonewton. This is the first step. Then step number 2, P force analysis. P force analysis means the whatever the truss is given, whatever the load acting on the truss as it is, reaction is already known to you, and we have considered uh, uh, every joint. For example, when we consider the joint D, there are two unknowns. And we know that in case of truss, this is the concurrent force system, that is all the forces passing through one point. And therefore, we have applied the two equations. Summation Fx or summation H is equal to 0. Horizontal reaction is equal to 0. And summation Fy or summation V is equal to 0. And that's why when we consider the joint A or joint D, in analysis of truss, of course, it is the lengthy, but if you observe something, joints, we can easily find out the forces in most of the members. For example, in case of joint A, here it is observed that VA is already known to you, that is 35 kilonewton. EHA is also known to you, that is 37.025. Okay, and this VA is related with in the same line of force in the member AC. That's why this will be pull. That's why this member is also pull. That is the tensile. So can I say directly the force in the member AC is equal to VA, or summation Fy is equal to 0, we get the value of force in member AC. Similarly, when we apply the summation Fx is equal to 0, HA and this in opposite direction, that is the force in member AB. So force in member AB is equal to HA and force in member AC is equal to VA. No need to consider the joint. We can directly write down this one. Okay. Then we have considered the joint D. At joint D, there are two members. One is the force in member DC and force in member BD. These are the two unknowns. That's why we can consider the joint D. And when we consider the joint D, there are two external forces, 15 kilonewton and 35 kilonewton. So this is the free body diagram of joint D. 15 kilonewton, 35 along the force member. The force CD is there or DC is there, and along the member DB or BD, the force in member DB. This angle is 60 degree. Okay, and therefore we have resolved this force along the x-axis and the y-axis. Therefore, we have applied summation Fy is equal to 0, FBD in vertical direction into, this is the cos theta, why sin theta, why, because 60 degree is with the x-axis, that's why y component is sin. So FBD sin 60 in upward direction, that's why positive, minus 35 is equal to 0. So we get the force in member BD 114.82. It is positive, that means the our assumption is correct, it is tensile member. Similarly, we have applied summation Fx is equal to 0. In x direction, FCD is there, minus, because this is move in this direction. So, plus 15, and this component, that is force in member BD into cos 60 is equal to 0. FBD is known to you, and that's why we get the force in member CD that is equal to minus 94.36. Minus sign indicate the given force is compressive. Here we have considered the tensile. Okay. Once we know this force, then we can consider, we have already discussed the joint A, we have discussed the joint D, and last we have considered the joint C. At joint C, there is an inclined member, horizontal reaction at C, and force in member CD, which is compressive, and force in member CA or AC. So from this we get the force in member CB. Apply the summation Fy is equal to 0 or Fx is equal to 0. Okay. So we get the again minus 114.82. That means minus sign indicate the force is tensile. Sorry, compressive, not tensile. Initially we have considered the tensile. Okay. Now this is the P force analysis. This is the diagram which indicate the which force is compressive, which force is tensile, like that. Okay, so this is the P force analysis. That is the step number 2. Then step number 3 is related with the K force analysis. Now in K force analysis, we want the vertical deflection, and that's why we can apply, after removing all these external forces, we have apply the 1 kilonewton force in the vertical direction at D. If we require the deflection in horizontal direction, in that case we can apply the unit load in the horizontal direction. Okay, but in this problem we want the vertical deflection. That's why after removing these two forces, we have applied the unit load. Okay, so here we have applied the 1 kilonewton load. I can show here, right? So as per the assumption, this is my assumption, 1 kilonewton, it is downward. If the answer is negative, in that case, my assumption is wrong and we can change the direction, right? Okay, so this is the direction of 1 kilonewton load after removing 15 kilonewton in horizontal direction and 35 kilonewton load in vertical direction, and then analyze the truss. Repeat the same procedure here also. Because of this 1 kilonewton load, again we can find out the HA, SC, and we can say that the VA. Here it is observed that the load is vertical, and that's why these horizontal reactions, these horizontal reactions are 0. Here we have considered, just a minute. Okay. Sorry. In this problem, uh, deflection is required not at D point, but it is required at the C point, I think. Yes. Just a minute. Joint C. Okay. The deflection is required at joint C, not at D. And therefore, we have applied the unit load. Therefore, we have applied the unit load at C. Sorry. Yes. So here it is already shown. Okay. We want the movement of the roller support at C, and that's why we have applied the 1 kilonewton load at C point. And therefore, here it is observed that this force passing through the same line, and using the principle of transmissibility, we can say that the VA is equal to 1 kilonewton. In upward direction, HA and SC is equal to 0. After application of summation Fx, summation Fy, and moment about any point is equal to 0, or during the observation, it is observed that this 1 kilonewton in the one vertical line, and that's why these two forces will be 0. Okay, so when we consider now for the we can say that K force analysis, here clearly observe that at point D, at joint D, there is no force, and that's why force in the member BD and force in the member CD is equal to 0. There is no issue. This is 0, this is also 0. This point indicates the 0 force. Similarly, when we consider the joint A, VA and AC in the same line. That's why this is 1 kilonewton. That's why this force is 1 kilonewton. Okay. And in x direction, AC is equal to 0. That's why this force is also equal to 0. Here this is 0. This is 0. That means here again there is no external force. That's why this force is also equal to 0. And that's why this is the K force analysis, which is very simple. Simple to understand and simple to get the forces in the all members. But only important thing is our observation. If we observe the figure, we get most of the forces without considering the joints. You just observe. And that's why again, this is the K force analysis. And after K force analysis, step number 4 is tabulation. Tabulate the results. So there are 5 members: AB, AC, BC, BD, and CD. Okay, and T force analysis, that is step number 2. We can write down compressive is minus and tensile is plus. That's why 37.025 tensile, AB member is tensile, that's why positive. 35 again tensile positive, but BC member is compressive, that's why I have written minus 114.82. Similarly, BD is again tensile and CD is compressive. Then K force analysis, we know that only one force is there, that is force in member AC, that is 1 kilonewton, and rest of the member, force in the rest of the member is 0. Length, again angle is given, vertical and horizontal distance is known to you, then we can find the diagonal distance, that is 3.46, like that. 2 meter 3.46, 4 meter 4 meter 4 meter, like that. Similarly, you can find out the A multiplied by E. The area of all the member is 1200 mm square, and the modulus of elasticity E is equal to 2 into 10 raised to the power 5. Convert this, we get the uh, um, A into E in kilonewton, 2.4 into 10 raised to the power 5. Then PKL, P multiplied by K multiplied by L, that is column number 2 into column number 3 into column number 4. Here K is 0, that's why all these will be 0, but only for AC member it is 1 multiplied by 3.46 divided by 2.4 10 raised to the power 5, we get the value of PKL. Okay, and the moment of the roller support, that is the deflection. Indirectly we can say that the deflection. So delta C is equal to PKL divided by AE. So PKL summation is again 121.1 divided by AE. We get the moment of the support C, roller support C, that is 50.45 into 10 raised to the power 5 meter. Convert it into mm. So it is 0.5045 mm in the downward direction. Positive sign indicate our assumption is correct. This is related with the, we can say that, analysis of the truss. Second problem, calculate force in all the members. Area is given, E is given, and again this is also similar problem, but here we can find out the forces in all the member because the truss is indeterminate. Generally we can find out the deflection in case of truss is determinate, and for indeterminate we can find out the forces in all the members. So in this problem 3 meter 3 meter, that's why the angle is 45 degree, this angle is 45 degree. External load 30 kilonewton applied at point C. And first of all, step number 1, we can find out the DSI, degree of static redundancy. Here one reaction is there at joint B, roller hinge support is there, 2 reaction is there, 2 plus 1 3, and the number of equations available are 3. That's why 3 minus 3 0. Externally it is determinate. But about the internal, M is equal to 1, 2, 3, 4, 5, 6. There are 6 members and joint are 1, 2, 3, 4. 4 multiplied by 2, it is 8, minus 3, that is 5. So here number of members are 6 and 2j minus 3 is equal to 5. That's why degree of indeterminacy is 1. Right? That's why we have considered any one member as a redundant member. Either we have considered this diagonal member or this diagonal member or any vertical or horizontal member. But when we analyze any truss, when we consider diagonal member is redundant, then most of the problem will be easily solved. Let us see the problem. So in this problem, we have considered First is the calculation. Just a minute. Calculation of degree of static redundancy, that is DSI. This is the first step, that is equal to, as I have already discussed, 1. Then we can find out the support reaction. Step number 1. Then step number 2, which is related with the support reaction. Here there is one reaction. Say we have considered RA. At support B, hinge is there. That's why two reaction. These are the assumed direction. This is RB and this is horizontal reaction HB. Of course, when we consider summation Fx is equal to 0, this HB is equal to 0. Okay. And here, if you observe this truss, this force acting along the same line. So we say, using the principle of transmissibility, RB is equal to 30 kilonewton directly, or we can apply the summation Fy is equal to 0 and moment about point A or B is equal to 0, we get the same answer. Okay, so RB is equal to 30 kilonewton and RA is equal to 0. Okay. Then step number 2, that is the support, find out the support reaction. Step number 3, that is related with the P force analysis. For P force analysis, again at joint D, or when we consider for P force analysis, remove any one member. That means the force in any member, say diagonal member, because the degree of redundancy is 1. Therefore, remove any one member. So I have removed this member, AC. Okay, when I have removed the member AC, can we say at joint A, there are two members, one is AD and one other is AB, and the RA is equal to 0. Okay, and therefore, when we observe this, it is observed that RA is equal to 0. That means the vertical external reaction is 0. That's why force in this member is equal to 0. Similarly, when we apply summation Fx is equal to 0, this is the only member connected with the joint A, and that's why force in this member is also equal to 0. Okay, that means this is 0, this is 0. Now we can consider the joint D. In joint D, again there is no external force. Summation Fy is equal to 0, y component of this member, that is vertical, and this is 0. So can we say this is also 0? Okay, and if this is 0, this is 0, we can say that this is also 0. Summation Fx is equal to 0 when we consider the joint D. This will be 0. And when we consider the joint C, it is observed that this is in the same line, compressive. That's why this force is also compressive in equal and opposite direction. And we get the value of this is 30 kilonewton compressive. That's all. That is the P force analysis. Right? We get the P force analysis. This is the step number 3. Then step number 4, K force analysis. For K force analysis, what is the requirement? First, we see the requirement. Deflection, calculate forces in all the members. Okay. Now in K force analysis, what is the, just a minute. Now in K force analysis, what happens? I have removed this force. Now in K force analysis, just a minute. There is a, yes, okay. Now in K force analysis, taken the front color. Okay. Hmm. Now in K force analysis, we have considered this AC member having the zero force, or we can remove this. In K force analysis, we have considered this member has force 1 kilonewton. I have considered tensile. It is not necessary consider tensile. It may be compressive also. This is my assumption. Tensile, and for this also it is equal and opposite. Say 1 kilonewton. Okay, and remove this 30 kilonewton load. That means I have remove this load. This load is zero. There is no load. Okay, and analyze the truss. Now again here it is observed that this is the external force. That's why no need to find out the external reaction, because this is the internal force. So this is 1 kilonewton. This angle is 45 degree, right? So can I consider this component is related with the cos of 45? 1 cos 45, that is 0.707. This is tensile. Therefore, this force is compressive, equal and opposite. That is 0.707, right? Similarly, when we consider this force, this is also 45 degree, and sine 45 and cos 45 having the same value 0.707. This is tensile, and that's why this component is compressive. That is the toward the application, and the value is 0.707. Here joint C is the same or mirror image of the joint A. Here 1 kilonewton, this is horizontal member, this horizontal member, this vertical, and that's why force in this member is also 0.707, right? And this is also compressive, equal and opposite 0.707. Very simple. And when we consider the joint D, this is 0.707, this is 0.707, and this is the diagonal member. This angle is again 45 degree, right? Here, this is 0.707, this is 0.707, this is 1, and therefore the force in diagonal member is again same, that is 1 kilonewton tensile. Now this is the K force analysis. This is the step number 4. Then step number 5, tabulate the result. We can develop the table in which members are there. There are total 6 members. You can write down the 6 member. Then P force analysis, that is force in all the members. In most of the members it is 0. Then the value of K force analysis, this diagram, and then length. The value of area is same. Therefore, we can consider P K L. Summation of this for all the 6 members and divided by A multiplied by E. Okay. We get the deflection. But here we want the forces in all the members, not the deflection. Okay. So what is the change? Here change is, we have considered the table in which P is there, K is there, L is there, and then we can write down, sorry, P, K, L. Then next, K square L. Okay, PKL, K square L, and then take the summation of this, and we can find out the correction factor. That is equal to minus sign summation of PKL. Summation of PKL divided by summation of K square L, because A is same. The value of A and E is same. That's why it will be vanish. So PKL divided by E, and here summation of K square L divided by E, we get pkl divided by k square by l. This is the correction factor. And then after applying the correction factor, we can say that the final force in the last column is equal to P force in each member plus K multiplied by correction factor. So we get the final force. This is the procedure. Okay. So from this, we can easily find out the force in all the member for a redundant truss. So thank you. Thank you very much.